Hello, today I'd like to talk about the airplane crash caused by the fatigue cracking, and mostly that the accident from that airplane was usually caused by the fatigue cracking, and also I will explain about the fatigue cracking phenomenon from the very basic one to the advanced one. So let's move. So this is the very long time ago, 1954, that named as the Havilland Comet. So that airplane, it was the departure from the Rome to the London. It was on the 1954 January 10th and broke up the 20 minutes after taking off. So the unfortunately loss of all 35 on board, and just the 3 months later, just like April 8th. So it was same departure from the Rome to the Cairo. So unfortunately, there is a loss of the all 21 on board. So when we think about that, why it happened, so as you can see, that window looks like a rectangular shape. Nowadays, you maybe had an experience that the airplane's window is a elliptical shape. So it means that at that time they didn't know about the stress concentration. So the stress is concentrated in the corner of that window. So it was really the huge problem. And also we are nowadays considering about the different pressure from outside to inside. But we saw that we have the two layers of the windows, but at the time it was just a single window, so it was not fully covered by the differences between the pressure from outside to inside. So that was the really the problem. So because of the stress is concentrated in the corner, and then it was really affected from the pressure differences. So the fatigue crack was initiated from that corner, so it is starting from that. So unfortunately, they had a very tragic accident. Another case is the American Airlines flight, the 191. It was in 1979. So we say that this one is legacy of the DC-10. So we can understand about the pylon part. Pylon is the connecting the wing to the engine, so it is very important part. For example, like a human, it is same as our neck. So it is connecting to our heart and our brain. Also, pylon assembly was separated from the left wing. So it means that engine was just fall down. So unfortunately, also they have 273 fatalities, and then it is caused by the asymmetric stall. So it is asymmetrically, they have the wings that the problem. So also it is important that fail to detect and prevent that improper procedures. So that is the point. So we need to examine that crack is initiated and propagated or not. So that kind of the observation is very important. We can understand that part. So it is a little bit different one. Also that in the not for the airplane. This one is for that semi-submersible drilling rig, so in the ocean. So we named the Alexander Killen accident, 1980. So due to the fatigue crack in the welds, so that they have some accident like that. So the welding, they have the things like when we do the weld, and then near that part, heat affected zone was formed. So because of that, the grain size increased, and then that it is a little bit different from that base metals. So that is a very weak part. So we need to consider the kind of maybe there's some kind of inclusions or defects can be existed in the weld part either. So fatigue crack can be easily initiated from that part. So that is very important to understand. So this is the important part for that we need to consider about that during the welding. Very sound welding is very important. And also, this is really the tragic thing, the Aloha Airline Flight 243, so 1988. So as you can see, here is the roof of the fuselage was just flow away. So in the Hawaii, so there are usually we know that there are a lot of the island. We know that Oahu and then Maui, and then like the Big Island and Kauai. So they have the from the departure from the Hilo to the Honolulu. So it was really the short trip. So it departed and then go to a little bit short time and then they arrived. So they have very exposed to that departure and arrival, and then so it is a little bit difficult to observe that. But at that time, and then multiple fatigue cracking was shown in that skin close to the river hose along the lap joint, but they didn't observe that a lot. So there was a very tragic accident was happened. So that there were 95 occupants and then 65 injuries. So we know that our the safety belt is very important for the when we just go into the airplane. And unfortunately, there is one fatality. So that she was the flight attendants, but she was unfortunately just float away. So we know that the quality of the inspection and then maintenance program was very important to understand that. And Sioux City, Iowa flight 232, it is 1989. So as you can see that when we think about the engines, so that is the engine, they have the blades. So in here, like the uncontained failure resulted from the engines. So the fan disc departing the aircraft. So when only the one blade is broken, so it is affected to the next one. So after that, so because it is rotating, so only the one blade is fractured, and then it is damaged to all that blades in the finally. So it is a really huge problem. So the kind of the non-destructive testing is very important. Things like the penetrate testing or the poor attention to human factors. So the very detailed that detection is very important to observe the fatigue cracking. So we can think about the fatigue cracking. So observation is very important. So if it is initiated, we need to observe that if it is growing very fastly or slowly. That is a very important part. And then this is Iche, and then in Germany. So there is a derailment, 1998. So most of that wheels nowadays, it is not like the monoblock wheels, but there is the monoblock wheels are just equipped in that. So because of that, they have exposed to a lot of the vibrations and resonance. So it resulted in metal fatigue. So that fatigue crack was initiated in the wheel. So after that, so it was broken, and then derailment was caused. So unfortunately, so they have the 100 the fatalities, and then mostly the 200 injuries. So as you know, the wheels they can experience around more than like the 500,000 times revolution during a typical day in a service. So it is very critical to for that fatigue cracking. So also it is very important that observation is very important. And as you know, this is a very famous about the crash. So Concorde crash in 2000. So Concorde crash was from the Air France flight. So first test flight was 1969, and then it was retired in 2003. So it is really fast, faster than the speed of the sound. So that it is a Mach 2 point. So it was around 2,000 kilometers per hour. So in the road, so for that departure for the airplane. So when the airplanes take off, so very small size of the metal piece was on the ground. So we can call that is the FOD, the foreign object damage. So because of that very small pieces of the metal, that it is just cut that tires of that airplane. So the tire debris, maybe it is the rubber, so it just go to inside of the engine. So because of that, the tire debris, it is about 4.5 kilogram. So go to the engine. So as you can see the photo, so it is inside of the engine was burned out. So it was really the huge problem. So it was a really the horrible accident. So it was happened. So after that, unfortunately, that Concorde was retired. So we can understand that there are a lot of the accidents can happen caused by the fatigue cracking or things other cases. So most important part is we need to observe that crack is existed and then or the crack is growing fast or not. That is the very important part for us. So the fatigue. So so maybe you can think that fatigue is kind of the cyclic loading. So cyclic loading is just induced to that materials, and after that, even though there is not overloaded, but the fracture can be occurred. For example, like even in the very under the yield strength, the material can be fractured. So that is the very dangerous point of the fatigue. So fatigue is very common in our experience. As I explained to you, the wheels, it is experiencing the fatigue. For example, like the car engines, it is going to the 160,000 kilometers. So it is usually 300 million revolutions is a lot. And also the truck wheels, it is typical life, it is rotated for the 500 million revolutions. So fatigue is not far from our life. It is very close to our life because we are always riding a car and the airplanes, and also we always experience about that cyclic loading. So that is very common to our life. So fatigue loading, so there is usually we can set for the constant loading. So it is starting from the minimum stress to the maximum stress. So we can say that is the range, but half of the range we can say that is amplitude. So amplitude is very important for that loading. So, and the one cycle we can say the cycle. So we can consider that. So minimum stress and maximum stress is very important. So in the average is we can say that the average stress or the mean stress. But the stress amplitude we can say that maximum stress minus to the minimum stress and divided into 2 is we can say the stress amplitude. We can see that in this using that these equations. And R ratio is also important, that it is minimum load is divided into the maximum load. So we can say the R ratio. And the amplitude ratio is the load amplitude over the mean load. So we can say that is amplitude ratio. So important part is that stress amplitude is very important, and also the R ratio is very important. So as you can see these figures, so we can think about that. The maximum stress is for example, like the 100, and then minimum stress is minus 100. It means that tension and compression. So it is divided into the maximum to the minimum to the maximum. Then it is minus 1. It means that R ratio is minus 1. So minus R ratio means that tension and compression. Sometimes it is go over. So R is like the 0.1. It means that, for example, like the minimum stress is 10 megapascal, or the maximum load is 100 megapascal. It can be just divided, and then it is 0.1. So that we can calculate the R ratios like that. And also there's stress amplitude, as I mentioned. So the maximum stress minus, and then the minimum stress, it is just a half, is for the stress amplitude. That is the basic thing for the fatigue. So in the fatigue, so SN curve is very important. So as you can see, so usually we can say that low cycle fatigue and high cycle, but usually the high cycle fatigue is SN fatigue. So the stress and then number of cycles. So as you can see, fatigue limit is very important like this. So we can say the fatigue limit or endurance limit or the fatigue strength. So it means that, so when we just consider about this one as a fatigue strength, so under this area, even though there is the infinite cyclic loading was induced, there was no failure for that fatigue cracking. So it means that when we get the high fatigue limit or high fatigue strength, it is good for resistance to fatigue cracking. So that part is very important part for that SN curve. And also we can explain about the fatigue crack propagation. So in the aerospace materials, not just only for that SN curve is important, also the fatigue crack propagation is very important, because even though when the fatigue crack is initiated, it is very important that if it is very grow fast or not. So here, so DADN curve means A is the length of that crack, and then N is the number of cycles. So it means that is the speed or the growth rate of the fatigue crack. So it means that we can be characterized to the region 1 and the 2 and then region 3. So in region 1, here is the delta K threshold is very important. So if it is when the delta K is lower than this part, so the fatigue crack is not grow, and then just for this stage 2, so we can see that this is for the log relationship. So DADN equals to the C delta K to the M. So it means when we just change it to the log scale, then that is the slope is just for M. So we can say that is the Paris law. So it means that they have the relationship for increasing the delta K. So it is for to the scale to the M, and then it is related to the DADN. So it means the crack growth rate is very important, and we can predict that. And going to that stage 3, so it goes to this area. So K maximum is same as the KC. So it is for the fracture toughness. So you can say that there is the preliminary for the fracture toughness. So here is the final slide. So the fatigue crack growth model, we can say that there are a lot of models. So it is divided into the fatigue fracture mechanics based, so the linear elastic geometrical and plastic accumulation, and also the dislocation mechanics based, so the crack, so dislocation is emission, and also sometimes the dislocation is blocked, and also the dislocation irreversibility, and it is not going back to anymore. So it is related to the fatigue crack growth model. So this is just for the introduction for the fatigue crack initiation growth model. And the next class I will explain about in the very detail about this part. So today I talked about that a lot of the accidents so caused by the fatigue cracking, and also it is really related to the fatigue crack. So we thought about the high cycle fatigue and then fatigue crack growth. So that is very important to understand aerospace materials crash, and then also the fatigue crack phenomenon is a very important part for the aerospace materials. Okay, thank you.